This talk is about database disasters and how to find them. So it always begins that you've just gotten into bed after a long, long day, and you get one of these texts. So, and you think, your first reaction is, no, don't wanna, can't make me. And then it's okay, fine, you'll have some instant coffee. And then, so you, you hop on Slack, and they say, here's the Zoom link for this incident. It looks like that. And this is because this is what the typical incident response is like. Everyone hops on a 500-person Zoom call. Everyone talks at once over each other. There's a vice president, often not even a technical one, who says, well, we've been down for 25 minutes, and this is costing us $83 billion in revenue every 3 minutes, because if he yells at you enough, the problem will go away. And then everyone just pushes buttons, flip switches, pushes out random code fixes, runs Terraform, and eventually the problem goes away. Why? Well, don't know, but I'm going back to bed. So, hi, I'm Christophe Pettus. I'm the CEO lead consultant of PGX. We're a boutique Postgres consultancy. We see a lot of database emergencies. We get called in a lot for these. And we see a lot of very badly managed database emergencies. So here's what we've learned, at least some of what we've learned about handling them. So we're going to talk about incident response analysis, some common problems that you can encounter with Postgres. There are whole talks, there's whole month-long classes about crew resource management. We're going to have one slide. Everything you need to know about crew resource management, kind of. So basically, how to avoid master cluster clucks. Okay. Analysis. Something bad has happened. The front end is throwing 500s, queries are running slow, the database server is down, or appears to be. So the first thing to do is have an incident response checklist. Have it somewhere that you can use so that if your internet connection from the office is down, you have access to it. I've had the experience of someone calling and saying, well, we have all this incident response, well, in this case it was, we have all our network information, but it's in Confluence and we can't get to Confluence. So that was a problem. So start with a checklist of things to check. Run this checklist even if you are sure you know what the problem is. 100% for sure you know what it is. Because many obvious problems are symptoms of a deeper issue, and this is how you get into trouble, by overanalyzing the problem early in the stage. For example, you see, well, queries are running slow, but what's really causing that is high I/O, which is being caused by high log volume, reporting some other error entirely. So what is the exact problem? Avoid speculation at this point. It's very common that we'll log on to an incident response call, they'll say, oh, well, we need an index. It's like, whoa, stop. Tell me where it hurts first. What actual symptom are you seeing? When did the problem first manifest? Frequently we'll get called on an emergency, and say, well, when did you first start noticing all this? And they say, oh, about 2 or 3 weeks ago. That's an interesting definition of emergency, but what they mean is it started, the symptom started 2 or 3 weeks ago, and now it's reached the point it's intolerable. And what have you done, what's happened so far, if anything? And please be, people are sometimes conservative with us, but we're like, we're your doctors. You can't, don't be honest with us. We've seen it all. We're not going to judge. We've screwed these things up too. And also, what's the business impact of the problem? We've been called in emergencies to say, okay, so what bad thing is happening that caused, oh, nothing. We're just, didn't like this number on Datadog. Okay. Again, interesting definition of emergency, but it is important to understand, so what's this breaking? And so as a policy, we do not immediately, when we're doing incident response, we do not immediately hop onto Zoom. Sometimes to the irritation of our clients, and I apologize in advance for that if you're one of them. But the Zoom call is a terrible way of handling this, especially in the early stages. We will go, obviously they're paying us. We will eventually go on a Zoom call if that's what they want. But the first thing we need to do is get some data. Because once you're hooked into this kind of high response environment like Zoom, you're going to be spending most of your time dealing with Zoom, not dealing with the problem. And so you need to make some progress first. So, for the initial data gathering. So, we're a database consultancy. We always assume the problem is in the database, even if looking at it we think, it doesn't really sound like a database problem. First of all, again, concluding that is overanalysis. Second, we're not network engineers. We're not going to fix the problem. And also, as a resource management thing, it's important that each person focus on the area of their expertise, because even in a small organization, people do know different parts of the system better. About 65% of the time, based on going over our incident reports, it wasn't a database problem at all. It's just the problem seemed to present itself as a database problem, or the database to the client was this big black box, and so they assumed that the strange noise they were hearing was coming from that. So can we connect to the database instance at all? In a managed instance, like you're on RDS or Google Cloud database, the brand names always confuse me. Can we get into the instance at all? If we can't, where does the interruption seem to be? For example, we have in some situations we had our own jump. PGX has our own jump host because we're scary outside consultants, and we can't get in through that. But everyone else on the call is saying, well, no, we can access it just fine, which is interesting. Either the jump host got shut down, and it's nothing to do with the problem at all, or there's some kind of network configuration thing. Someone pushed out a bad security group, and suddenly everything stopped running. Can we get anywhere in the network infrastructure? If connectivity into seems to be a problem, for example, is the primary, if it has a secondary, is the secondary accessible but the primary is not? Can we get to anything else inside of that subnet? That kind of thing. A very, very common failure mode, actually, is someone just does a Terraform deploy and doesn't notice the fact they've just screwed up their security groups, and they blocked the application from being able to get at their, being able to get at their database. Happens more often than you'd think. And what particular kind of connection failure is occurring? Is it being rejected? Is it timing out? That is very valuable data. This was really embarrassing. Check the hosting provider status so you don't spend 45 minutes trying to diagnose that US East 1B was down, which is what the AZ that was US 1B, because that did happen to us. We were like fighting this whole thing until someone thought, hey, maybe we should check this is really weird. Maybe we should go check Amazon's status page. It's like, well, no, like lots of people are down, not just them. So, okay. People have some kind of trauma around opening tickets with their hosting provider. You're paying these people a lot of money. Their whole unique selling point is they're supposed to keep this stuff healthy for you. Yet, we will come in and the incident is, and by the time we're notified, the incident's been going on for 2.5 hours, and we say, well, what does Amazon have to say? Oh, we haven't opened a ticket yet. Do it. Just do it. Really, you're not wasting their time. Or if you are, who cares? You're paying them. You can always close it later if you find out it's not a problem, that the problem was not one they could resolve. Also, keep it updated with more detailed findings. I mean, these people are, often you're dealing with pretty smart engineers on the other side too. They want this data as well. Okay, so you've decided that you've gotten to the point the database server is hard down. So the database server and only the database server is non-responsive. So check some monitoring metrics. Are they capacity related or an instance failure? Sometimes we will get into the situation where it appears to be hard down, but all the metrics are showing that it's just sitting there waiting for a connection. So, which is an interesting data point. If you determine it's instance related, just fail over and ask questions later, if you have a secondary and all that. Because the goal of an emergency is to get yourself back on the air as fast as possible. It's not an intellectual exercise of let's try to diagnose that, let's all, learn things about diagnosing a problem. That comes after. If it seems to be capacity related, like the database is to the point that connections are saturated or something else, find the source of the load before just failing over, because frequently in this case, more often than not in fact, you will fail over and the new primary will just start exhibiting the same problem the old secondary did. Okay, so you've determined it's capacity related. It's running out of connections, for example. You're getting connection refuse errors, or there are just lots more hot connections than you're used to seeing. How is the I/O doing? Is the I/O near saturation? Or, although this is less and less frequently an issue, I've noticed. If it is I/O, try to figure out what the source is. Most hosting provider graphs are horrible at this. They'll just say, oh, you're doing 8 gazillion IOPS, but it won't tell you anything. Are they read side, are they write side, or you have to drill down farther to see that data. Is it wall related? Is it logging? One of the unfortunate characteristics of many hosting providers is the Postgres text logs go to the same volume as the database. So even though that you are not saturating the database in terms of I/O operations, you can kill it just with logging. How's memory doing? Are you, is the instance swapping, for example, or are you running out of freeable memory? Do the logs show heavy work mem usage? It's checking the logs, unfortunately, on a lot of environments is a little bit tricky, but this is often a very good sign that something as bad has gone on. And how's the disk usage? Is disk starting to fill? Is it relatively stable? Is it being eaten up? Is it near exhaustion? That kind of thing. Check the logs. This is often something we have to really prod people to do or remember to do. Obviously, if we're on the word handle it and doing it, we'll look at them. Are you seeing errors in the logs? Really kind of a basic thing. Are you seeing excessive lock weights? And have you turned lock weights on, which is important. Are normally fast queries suddenly showing up as slow? Something that's really, really important to your system. If it runs in longer than 7 milliseconds, everything's going to fall apart, and now they're taking 4 seconds. Are you seeing connection storms? A whole bunch of connections opening at the same time. Lots of temp file activity usually goes along with work mem, although we have seen situations where log temp files was not set to 0, but was to some higher number, and tons and tons of temporary files were being created under that threshold, so they weren't getting logged, but they were bogging up the system. So what symptoms are you seeing at the application? What errors is the application getting, if any? Are they timing out? Are you getting connection refuse messages? A very, very common failure mode is that in a lot of stacks is that once the database starts slowing down, the application says, well, that won't do. I'll just create a bunch more threads to get the work done. And the situation spins out of control in no time at all. So it's basically designed to destroy the database. Is the application unable to connect even though we can with PSQL? So this is not an uncommon failure mode. Again, often because of a bad system configuration that was just pushed out, is that we can PSQL just fine. We don't see what the problem is, except that there are no queries being run by the application, but that looks great to us. But the application just can't get at the underlying, so, like, is there a networking problem? Or, again, security groups, whatever. Have you just changed your PG bouncer configuration and didn't bother telling us until 45 minutes into the call? This is also can be an issue where there's been a change to a front-end pooler. Often they will make the change to front-end pooler in a slack period, reasonable enough. You want to minimize disruption. But then once a busy period comes along, the pooler, the new configuration is unsuitable for what's going on. Yeah, here's this is that the application just starts firing up threads. Modern stacks, which have auto scaling on the front end, are really subject to this issue. Take a look at the onset pattern. You're not gonna be nice. Okay, there we go. Was it sudden or gradual? Again, you want to pursue different paths if this is something that's been building for weeks and it just reached a point of the threshold that you just couldn't deal with it anymore, or was there a sudden cliff up or down for the problem? Is it correlated to a particular process? And by process, I mean business side process in the system. Like, is there a background task that wakes up once in a while and does this stuff? Is it correlated to auto vacuum activity? I do kind of joke that it's never lupus, it's never twins, and it's never auto vacuum, because people blame auto vacuum instantly for everything in Postgres, but it does happen that Postgres that an auto vacuum process will kick things over because of using too much I/O or something. Is there a locking situation? Things are piling up on locks, like, especially now that we have better tools for monitoring Postgres. We have things like Performance Insights and PG Analyze. Suddenly these lightweight lock backups have become more visible and people are reporting them more. Any sudden metric changes, even if it doesn't seem like it would be directly related to the incident. I/O latency or throughput goes up or down suddenly. And the problem distribution, is it on the primary, is it on the secondary, or is it on both? Are there if it's on both, or, well, in any situation, what are the load distinctions between the two? Are you using the secondaries mostly for redistribution, mostly as failover targets? Is replication lag increasing or spiking? Are there changes in the replica configuration correlating with the problem, such as new config files being rolled out? And code-related stuff. Was there a recent deploy? And recent does not have to be that instant. A code deploy, even within a couple of days, is worth taking a look at, because often these things require the code change plus a new load pattern. Config changes, of course. Did you just push out a new PostgreSQL.com for a new parameter group? Did you increase or decrease connection limits, play around with your pooler, that kind of stuff. Obviously, you want to check if there's unusually high or low query volume. Individual query performance changing. Again, did the 7 millisecond query suddenly go crazy and require 10 seconds to run? Changes to query plans. Very, very, very common reason for Postgres to fall over is that suddenly a query plan just flipped over. Mostly when an index scan gets switched to a bitmap index bitmap heap scan. Large resource-consuming queries. For example, the big data summarization job that marketing demands suddenly got turned loose during a busy period, that kind of thing. Long-running transactions. Is the XID age on the database unusually high? Is a manual vacuum not recovering old tuples? Is the number of tuples it's saying it could not recover getting higher and higher? And session state. Are there lots of idle in transaction sessions? This is because often you can get away with this. There's a tendency for organizations to not really notice that until suddenly something horrible happens. Lots of sessions waiting on lightweight locks. Is there a very high session churn rate? Because for opening a new backend connection to Postgres is not cheap, and you can in fact slam the system very badly if the connections are churning very rapidly. Okay, you've got all this information, so what to do? It would be great if we kind of had a decision tree saying, well, if it's this, then do this and this. The problem is right now, in our experience, at least my experience, there's just the problem space is too large to have a good decision tree. We tend to work by exclusion, eliminate the things that just can't be. If we can connect to the instance just fine, the application can the instance just fine, it's not a network issue. So and look at the things that can't be. Sometimes issues can mask each other, but this is, I think, more useful than just trying to walk a preset tree. And also, don't underestimate hunches, especially if you have a lot of contact with the technology. If you have a hunch, at least gather the data to eliminate it. And of course, map to previous incidents. We'll talk about this a little later about organizational ways of handling this. Okay, that all being said, we're going to go over some actual slightly sanitized incidents that we responded to semi-recently, and what happened and how we resolved them. But every unhappy database is unhappy in its own way, and the taxonomy of possible issues is pretty much infinite. So we're going to review some interesting ones, understanding that the idea here is to sort of get into the mindset of how you diagnose these things. Okay, problem one, site suddenly fell over. The API just started throwing 500s. There were no obvious alarms coming from the database. The database seemed fine. So we logged in the database. It was running lots of queries, but they were all finishing. No errors, nothing interesting in the logs. But I take that back. There was something interesting in the logs, which is there were bursts of slow queries. It was like the system would run a log and suddenly there'd be a burst. It would recover, keep on going. The API logs were showing lots of timeouts or inability to get a connection. And then we ran the slow queries out of the logs, and we ran them manually, and they were taking 10 milliseconds, which was totally normal. But the log showing them running in 2 seconds or more, which was pretty clearly the origin of the problem. Okay, so let's try analyze on the relevant tables. Maybe the stats got out of whack. Bad plans. Nope, that didn't work. Was I/O capacity being exceeded, and just the queries were taking a long time because of that? No, it wasn't even close to saturating I/O. Let's try adjusting the number of the pooling to reduce the number of connections. See if that helped. No, unfortunately, the slow queries were taking up all the connection slots. That caused timeouts, and then we were still getting 500s. The relevant table was very badly bloated, though. It was like 80% bloat, depending on how much you believe your individual bloat query. So we tried to vacuum analyze on the table. Okay. We broke the replica doing this because it was sending a huge burst of page changes down to the replica that were call-ins and query cancellations, but it didn't help the primary problem, so that was embarrassing. Then we got more accurate parameters for the local bad query. One of the characteristics of this is we were seeing a lot of $1 in the logs, but not a lot of query values. And so we were running with what we were supplied as typical query parameters, which were wrong. Well, they worked, but they were not actually typical query parameters. They were just they were ones that the client had just grabbed. And this was a plan flip. An index-only scan had become a bitmap heap scan. And it went from 4 to 8 milliseconds to over 2 seconds by doing this. But only on specific parameters. Not all the parameters that you could supply to the query had this characteristic. Unfortunately, the ones we were testing on worked fine, but the ones that the application used all the time weren't. So that was an interesting pedagogical lesson. So we rebuilt the badly bloated index, because of course the index was bloated along with the table. Everything worked fine. Problem vanished. So the origin of the problem was the relevant table was queried very heavily on the replica, because high read load, they've moved the read load to the replica, no problem there, and hot standby feedback was turned on. So in effect, vacuuming of the table was defeated, and so it was bloating up. And thus, the bloat got to the point that the planner decided, well, expensive to scan this thing, I'm going to do this instead, and broke the query. So we put in place actual bloat monitoring, which was not in place before. We ultimately rebuilt badly bloated indexes routinely on a nightly basis. The obvious thing to do would have been turn off hot standby feedback, but that created so many query cancellations on the replica, it basically made the replica useless, so that didn't fly. Okay, so this was an engineer got very, very, very lucky this time. Is that the clients, an engineer at the client was like, this PG Badger thing. I'm reading blog entries that mention it. Maybe I should test that out. So they set it up and ran some PG logs from it, and they discovered XID wraparound messages no one had been noticing before. And they did some math, because it told them how many transactions there were, and they could go in and see kind of what their transactions were. And it told them shutdown was about to happen in 2 hours. So they called us to fix it. An auto vacuum to prevent XID wraparound on the oldest, in terms of transaction IDH, had been running for a few days. I think it was 8 at that point. It hadn't completed its first pass through the indexes yet. So this was not going to finish in the next 2 hours. So we examined the table, and the table had 23 indexes, including 3 GIN indexes. And this was a big table. This was a 3 digits of gigabyte table. Oh, yeah, 178 gigabytes in particular. So what happened is sometime in the past, an auto vacuum to prevent XID wraparound woke up on this table and destroyed their system because they, nap time, sleep time hadn't been set right or whatever. And they say, well, this is not unacceptable. So they went and read some blog entries, and they bumped up auto vacuum max freeze age to 2 billion and vacuum freeze table age to 1 billion, and the problem went away. Until now, but the problem is, in the remaining number of transactions you get after those, there was no way of actually vacuuming the table successfully, or freezing the table. Fortunately, they had just recently upgraded to Postgres, well, semi-recently, obviously the thread's been running for a while, to Postgres 12. So we were able to do a vacuum with index cleanup false, killed the auto vacuum freeze and ran this instead. And this finished in about 45 minutes, so we had, by the time we were done, we had about 12 minutes to spare on the system. Worse yet, it was on RDS, and if you get one of these vacuum-free shutdowns on RDS, you file a ticket, and they'll get to you. So the nice part about this is this just is a minimum to freeze all tuples. It doesn't do the index cleanup. And then we did a more traditional vacuum to clean up the indexes because the system was out of danger. So mitigation 1, don't do that. We also bumped up maintenance workman to help speed up the auto vacuum process, although you hit diminishing returns on maintenance workman pretty fast. And we added XID age monitoring, which they did not previously have. And we dropped the unused indexes. About half those indexes were actually not being used by queries. So, this one took years off my life. The site just suddenly fell over. And this is a big, I can't name the client unfortunately, big, very public, makes hacker news when they go down kind of site. And it only happened between 9 a.m. and 10 a.m. Pacific. The only time it happened. The database just seemed to freeze. The operation, everything would stall for a few seconds and then complete. But high volume site, obviously, that's as good as being down. It only affected queries on the primary though. The replica just kept chugging along. Okay. So it was RDS, so we hung out on Performance Insights, their monitoring tool, during the bad period. And suddenly a huge burst of sessions waiting on various multi-exac lightweight locks would appear. There would be a few minutes of badness, and then everything cleared in. Okay, it's not good. So we eventually got it down to this. So it's not Twitch, to be clear. I'm just using this as an analogy because people kind of understand what Twitch does. So what if you're building a site like Twitch? You might have Twitch doesn't do this as far as I know, but you might have a streams table, you might have a users table, you might have a users watching stream table that says, that's the many-to-many table that says this user is watching this stream. Okay, that's, probably a horrible data model for Twitch, but it's understandable. So, but what happens, let's say a really popular streamer signs on and everyone wants to watch this person. You get tens of thousands of records all being created in user watching stream at the same time, within seconds of each other. Each of which has a foreign key into both streams and users. Each one of those insert statements takes a key share lock on the same single row in streams, right? Which means Postgres has to use the multi-exec system, right? But the multi-exec data structures in memory have a limited size. At some point, it has to start spilling that off to secondary storage, because if you have literally 25,000 sessions locking a single row, that's a pretty serious multi-exec situation. And this is a very slow operation in certain environments. Aurora is particularly slow at this. So, but why 9 a.m. to 10 a.m.? Because at that point, a batch job would come through and clean up all of these because eventually you stop watching the stream, the record doesn't get immediately deleted, and it comes through and cleans them up in batch because they discovered cleaning them up all when the streamer ends was causing other kinds of problems. Okay, fair. And sometimes between 9 a.m. and 10 a.m. is when this job ran, which was also happened to be one of the times the most popular streams started their show. So, ultimately, we ended up dropping the foreign key constraint and relied on the application handle consistency. As a database person, this gives me indigestion. It worked out, though. We moved stream joining into a batch process, so above a certain rate, they started queuing up so that not as many of these were all being created at the same time. We created a lot of these in a single big we could also create them in a single big transaction rather than bang, 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 insert. That helped a lot. Pay the big streamer to start at 12:30 p.m. instead of 10 a.m. They actually suggested doing that. That was their first proposed mitigation. Oh, we'll just write the guy a check and it'll be fine. Fortunately, there was a technical fix to the problem. So also, they moved the cleanup job to an adaptive low demand period where they just looked at how many people were watching stuff, and then the job would wake up and clean up for a while. So yeah, that was fun. Upgrade Follies. So upgrade an RDS instance from 9.6 to 10. Obviously, it's been a while since this incident. They had a brand new, well-reviewed parameter group for version 10. So they weren't using they didn't just migrate the 9.6 one forward. They had a brand new one. It was great. The upgrade went very smoothly. The application being back up success. Well, except the CPU started spiking regularly, but very unpredictably. Just boom, up to 100, go for a while, drop again. It was not clearly related to workload. There was no particular correlation anyone could see. No individual query was being run during that period that we could point out and say, that one, that's the bad one. I/O was doing fine, but the CPU pegs by themselves were enough to cause significant application problems. Okay, clearly the new parameter group, right? So revert the parameter group to exactly the 9.6 settings, because they'd made other changes, like you do, as they roll forward. Nope, that didn't help. Let's move all the traffic to the read replica and hope the replication lag is not going to be a big problem for the application. Nope, that didn't help. Bad instance. This is a sign of desperation when you start thinking, oh well, maybe we just got a bad instance, because it does happen on various cloud providers, but Amazon in this case, that you get an instance that has problems, but it doesn't happen often enough for it to be the go-to solution. So, but that didn't help either. We failed over to the multi-AZ replica, which is clearly not on the same physical hardware. Nah, that didn't help. Okay, now we're getting really desperate. This is like, we're saying it must be a bad EBS mount. For a while, I was just blaming everything on EBS. I still do, but I try to be a little more selective. So yeah, different EBS. This was a large enough customer they could coerce Amazon into guaranteeing that they had moved an EBS, the EBS mount. That didn't help either. It was getting to this point. Like, okay, it's zodiac. It's astrology. It's something like that. We did finally turn up the logging, because the logging was not very it wasn't very verbose on this. Not horribly unreasonably, because it was a very busy system and they didn't want to choke the system with logs, but this was an emergency. And then we noticed checkpointing was happening almost continuously. Like, it would stop a checkpoint and immediately start another one, 100% of the time. But that's weird, because the workload was the same, the checkpoint parameter settings were the same, everything was one parameter wasn't the same, but it wasn't obvious. Because in 9.6, max wall size is in 16 megabyte versions. In version 10, it's in 1 megabyte units. Now, if you're editing PostgreSQL.conf, you never care about this. because you specify the units and Postgres changes it to its internal units, right? But in RDS, you don't get that feature. The settings group is in Postgres's internal units, and and you just have to do the math yourself. So max wall size had been cut by a 16th when we using the same value. So we updated expensively, mostly they, but in concert with us, updated Terraform scripts to be able to specify units. Actually, like queried PG settings. It was a lot of work. And we scolded AWS that documentation didn't mention anything about this. Okay, and death by subtransactions. Site suddenly falling over. The primary symptom was that insert statement on the primary was just taking a long time. That randomly an insert statement would just take, seconds, where it normally took single or low double-digit milliseconds. Hadn't done anything, hadn't pushed out any code in a week. No significant changes in workload. No obvious monitoring issues. Everything looked fine. But subtransactions were frequently waiting on subtrans SLRU. Okay. Which indicates one of the typical thing this means is lots of individual transactions with lots of active subtransactions. But where are these subtransactions coming from? The one thing we could do is set query logging very low. Log min statement age, max statement age equals. Forget the parameter name, Google it, but it equals 0. Suddenly I can't talk. But the query volume was just too high. We would destroy the system just by doing that. And they weren't using PGSQL. The reason this is relevant is PGSQL exception blocks are implemented by subtransactions. It's frequently the way that people who are not actually using the save point command will get subtransactions. Developers swear, up one side, down the other, they never used subtransactions. The problem showed up without any recent code changes. And by recent, we mean like the last 2 or 3 weeks. Like, okay. This was a Django application. I'm a Django committer, so I had this idea, and I went through the code looking for the atomic decorator. This is a Django ecosystem Python decorator that wraps database operations in transaction. If you're familiar with Python, it's kind of nice. You say with atomic, blah, blah, blah. Bunch of code, and it wraps all of the database operations in that context manager with a transaction. Very convenient. If a transaction isn't open when it starts, it creates one. And if it's used within a transaction, it creates a subtransaction to emulate nested transactions. So over a month before, an atomic decorator had been added to a recursive Python function. Why it was recursive is it walked an internal tree structure and inserted rows based on what it found. Huge oversimplification, but correct for the point. But a code change in a completely different part of the system, not actually a part that the developers who are familiar with the database maintained, caused these trees to go from 7 to up to about 7 layers deep to 100 plus. So suddenly a single transaction could have 100 or more active subtransactions, and bad things started to happen. So rewrote the function to do tail iteration instead of recursion. Their code review checklist was expanded to include the transaction model, and there was another one that I actually didn't mention here, which is Atomic does let you say please don't create a subtransaction if there is one open already, and they set that everywhere. And we yelled at the person who had the idea of introducing subtransactions into the Atomic decorator, which would be me. It's actually my code. So yeah, I'm really sorry about that. I terribly sorry for the inconvenience anyone who crashes their system with Atomic. Okay, so let's talk about process a little bit. The first thing, the most important thing to my mind is when there is an incident, the responsibility is collegiate. That is to say, everybody's job to get it fixed, no one's responsibility to shoulder the blame. Save it for performance review time. Don't do it on the Zoom call. So I'm a private pilot, and one of the things about being a private pilot is you get familiar with the NASA's safety reporting system, where you can fill out a report of something that you thought was unsafe, even if you personally did it, and you cannot be penalized for the information you report. Of course, the FAA may come at you for other reasons, but you can't incriminate yourself with this. It's a very, very powerful system because it really encourages pilots to file reports on things that otherwise would have gone completely unnoticed. I filed them, So, also, if one person is able to break a site, the process is to blame. It's you want to establish processes that prevent that from happening. I will say, dealing with lots of organizations, and PGX has clients from Fortune 5 companies all the way down to a Montreal bakery. The incident response style is the most diagnostic thing I've ever found of how mature the organization is. The more technically mature, both in terms of process and organizational leadership, the better the response style will be. Okay, this is the promised one-slide crew resource management. Crew resource management was originally called cockpit resource management. It was intended to keep airliners from flying into things because people were talking over each other and no one knew who was doing what inside the cockpit. And this caused multiple plane crashes before this was developed as a discipline. Here it is boiled down to one slide. Everyone has a specific role and everyone knows everybody's role. You don't have everyone running around pushing random buttons. Each person is responsible for a particular section, ideally one they know very well. Everyone is empowered to make observations and communicate with them. One of the reasons this was introduced is co-pilots did not feel like they were allowed to correct the pilot because they're the co-pilot, the other person's the pilot in command. That's a bad idea. Have one person who coordinates, but that person is not the boss who silences people or does like, is that you have one person whose only job it is to manage the workflow. And everyone knows what steps are being taken. Nobody's off doing things silently. You say, I am going to do the following. In an ideal situation, the coordinator acknowledges that statement. This sounds like pantomime, but it really works. And if it's a major step, somebody double checks what you're going to do. They cut and paste the scripts into chat, something like that. Somebody else looks at them because this is often happening at 3 in the morning when you're in a panic. You're going to screw up. And follow the documented procedures until you run off the end of them. It's very easy to get to a point, get frustrated and think, I know what's going on, I'm just going to do this. Don't do that. Really the difference because taking an extra 30 seconds to do things is much better than screwing up and having the site be down for another 30 hours. Take notes and keep all the parts. What I mean by keep all the parts is, to the extent possible, and work very hard not to do anything irreversible. Sometimes, like we've been called in to patch on disk a 23 terabyte database. It's kind of hard to do a completely irreversible step there, but to the extent possible, we try. So, communication channel protocol. If you're in an organization of any size, there will be lots of people interested in the fact the site is down. Many of these people will have lofty titles, often beginning with the letter C. There should be a person whose job it is to communicate with these people and keep them informed. A single person, that's what they do. On the communication channel, focus on what you know and what you can do, not, oh, that was a bad, oh, that code push I didn't like, and and start relitigating a code review a week ago. Listen carefully and don't talk over each other. I know this is hard for engineers. Engineers are very bad about listening and not talking over each other, but it's a useful skill. And keep notes. I really prefer Slack over Zoom for this. Slack has its own issues, because Slack at least is self-documenting. Everything that happens in Slack gets recorded. And I realize this is hard, but you need to, somebody fairly lofty in their organization has to do this. If management is not actively working on the problem, they need to stay off the channel. This is hard to accomplish sometimes, but first of all, they're not adding value. Second of all, everybody's going to behave differently if the person 3 levels up from the person who does their performance review is listening. So have the person in bullet 1 talk to the people in bullet 5. Okay, well, yours are fine. Sorry, don't mean to offend anyone, but those other people, all their incident reports are terrible. They tend to be, this happened, we did this, the problem was resolved. No one cares really, it was fixed. That's what they care about. The thing you want to do is build institutional knowledge. You want to document which symptoms were the actual indicators. If we had seen this symptom and this metric right at the start, we could have fixed it much faster. That's useful information. These symptoms were irrelevant. We looked at the following things, but those were all red herrings. And distill this down. If you want to do the this happened, we did it, thing, that's fine. But the TLDR at the top should be, here's what would have made allowed us to fix this problem much, much faster. And here's why the fix worked. Blaming on human errors, like it was new. Humans screw up all the time. To err as human is correct. The goal, the whole reason we have process is to prevent minor screw-ups from becoming big ones. So focus on what can be done to prevent error escalation rather than, well, just don't do that. Because, well, just don't do that is very, very hard to inculcate in an entire organization. Follow the process is much easier. And after all that, the answer is usually better monitoring. Often, sites don't even monitor disk space, which is often one of the first signs that something has gone sideways on Postgres. XID age, read the logs, process them through something. You can be low-tech and use PG Badger, you can be high-tech and use Splunk, but process them through something. Look for sessions waiting on lightweight logs. We now have visibility into that where we didn't kind of really have much visibility before. That's very handy. One thing we're now doing is we're taking some exemplar queries and we're running them and looking at the plans on an automated way. So if we see something flip, we can respond right away. Huge bugaboo of mine. If everything's an alert, nothing is. There is a particular organization I'm involved with where I'm on the IT team. I get 700 Nagios alerts a day. Are any of those important? Don't know because I throw them away. It's like I'm not going to be able to process 700 Nagio alerts, especially when every one of them, for me to respond to, require my logging in and poking around in the system. Come on, be real. High alert volume is worse than useless because it trains people to ignore alerts, just like I've been trained to ignore those alerts. I just wait till somebody pings me on IRC and says, by the way, this is broken. Set alerts to mean a human has to deal with this right away, that something's on fire, or at least it's smoking. For things like, this situation looks iffy, use logs and dashboards. Don't use alerting. And there's the talk. This thank you slide crept up on me unexpected, but so that's a process I need to fix. So thank you, and there's my contact info, and questions. Oh, come on.
All right. Come on, it's going to be a question. Well, very complete then. Thank you.
Yeah. Really, really, the one thing you should get from this slide is it's okay to ask questions for this talk.
Yes, when you mentioned about tuning the vacuum, notice that you have tuned the maintenance workmem. What do you think about auto vacuum workmem?
I'm sorry, could you repeat? My hearing is just the worst thing ever. My
yes.
apologies.
When you mentioned about tuning the auto vacuum, yes, I noticed that you have tuned the maintenance workmem. So what do you think about auto vacuum workmem?
Set it to 2 gigabytes and forget about it.
Okay.
Yeah, unless it's a particularly small instance. You can, more is better. you know, but there is a curve. I mean, I'm drawing it like there's this real curve I could write on graph paper. Don't take that from it. But above, there is diminishing returns above about 2 gigabytes. You can start there. If you have a a really high memory system, you know that maintenance work mem, assuming it's being used just for vacuum, is ever going to be more than the number of workers times maintenance work mem. So you can splash out on a much bigger, go to 4, why not? Live a little. But generally I just set it on any modern instance, I set it to 2 and then don't worry about it unless there's a very specific problem I think it'll help.
Okay. But my understanding, I mean, if you tune the auto vacuum work mem, you will not use your maintenance work mem. I mean, vacuum will not use maintenance.
There is now a separate setting that you can just specify auto vacuum work mem.
Okay.
And you, so it's a good feature. I haven't used it that much because the other processes that use maintenance work mem, specifically index creation,
okay.
Again, do I really need a different value for it? I guess is but yeah. So I don't have any more specific advice for that. It seems to work.
Well, I think we are out of time, unfortunately. It is time. But will you be available for questions afterwards?
Of course.
Awesome. Well, thank you very much.